So in previous video, we learned that how to check an differential equation is an exact or not. Okay, so exact means for any first order first degree, which is denoted by mx plus m dy equals to 0. So this equation is said to be exact if it satisfies the condition del m del y equals to del n del x. Okay. And when this equation is said to be not exact, it's very easy to understand if this value means del m del y is not equals to del n del x. Okay. So now the question is, if any equation is not exact, then how to solve those differential equation? So then we have to, if any equation is not exact, then we have to find integrating factor and multiplying this equation with integrating factor, we get a exact differential equation. So this is the method to solve any non-exact equation. But the main problem is how to find integrating factor. So in this lecture, we will learn how to find integrating factor for any non-exact differential equation. Okay. So differential equation which are not exact can sometimes be made exact after multiplying by a suitable factor, and this factor is basically a function of, it can be any constant or it can be any function of x or y, even it can be a function of x and y. Okay, it's called integrating factor. So basically there are 5 rules to find an integrating factor. Okay, suppose the first order and first degree differential equation is this, we consider it's our first equation. Okay, so now the first rule say that if del m del y minus del n del x divided by n is only function of x, then the integrating factor will be e to the power integration fx dx. Okay. Now the second rule say that if we divide this difference, means the del m del y minus del n del x, if I divide this difference by m, and if it is a function of y only, integrating factor will be e to the power minus integration g of y dy. Okay. Now the third rule is if m and n are both homogeneous function in xy of same degree, and also m into x plus n into y is not equals to 0, then we can say that the integrating factor is 1 by m into x plus n into y. Okay. Now the fourth rule is, if the if the given differential equation, we can write this differential equation in the form of y of any function of xy dx plus x into g of function of x. It's basically g of xy means g is a function of xy, and here f of xy, it means that f is a function of xy. Okay. Uh, if we can write this differential equation in this form, then the integrating factor will be 1 by m into x minus n into y. Okay, if this value is not equals to 0. Okay, and last rules, it say that if the differential equation 1 can written in the form of this, a to the power a, y to the power b, in bracket m into y, m is definitely a constant, m into y dx plus n into x dy plus x to the power a dash y to the power b dash in bracket m dash y dx plus n dash x dy, okay, equals to 0. Where each and every a dash, b dash, m, n, m dash, n dash are all constant. Okay, then we can say that x to the power h into y to the power k is an integrating factor of this equation. How to find the value of h and k? We can find the value of h and k by this equation. A plus h plus 1 divided by n equals to b plus k plus 1 divided by n equals to a dash. Okay, so there are basically two different equations. Just calculating their value, we can easily find the value of h and k. Okay, now try to understand how to apply this rule to find an integrating factor. So let me solve the first equation. Okay. Okay. So if we compare this equation with the general form, so we can say that the value of m is xy square minus e to the power 1 by x cube, and n is minus x square y. Okay. Now calculate del m del y to check this equation is exact or not, and also del m del x. Okay. So what will be the value of del m del y? Basically, we are derivative this m with respect to y. Okay. So it will be 2xy, and here this function means if x behave like a constant, then definitely e to the power some function of x, it's also a constant. So this derivative value of this derivative is 0. In a similar way, if we derivative n with respect to x, it will be minus 2xy. Now it's very clear that del m del y is not equals to del m del x. So therefore, the given equation is not an exact. Okay. Now we have to calculate its derivative. Okay. Okay. Now if we calculate its difference, so it will be del m del y minus del n del x. Okay. So what will be the value of this difference? It will be 4xy. Now you have to think in this way that if I divide this difference by because there are only two options, we can divide this by m and also n. Okay. So if we divide this difference by m, is it possible that this value become a only function of x? But instead of m, if I divide this by n, so it will be minus x square y. So it will be cancel out. Will be cancel out. So it will be 4 by x minus 4 by x. So we can say that it's only a function of x. Function of x. So therefore, the integrating factor here, it will be e to the power integration minus 4 by x dx. Okay. So e to the power minus 4 log x, because integration 1 by x is log x. So it will be e to the power log of x to the power minus 4. So it will be 1 by x to the power 4. This is our required integrating factor. Now how to find general solution? Okay, for the general solution of the given equation 1 is integration m into integrating factor dx plus integration n into integrating factor dy equals to c. C being a arbitrary constant. Okay, here c is a constant. Okay. Now there is one thing you have to remember, that this integration, it will be x free. Okay, it's not sugar free, it's x free. Okay, so what is the meaning of x free? If there is any term which contain x, function x, we can remove this term from this calculation. Okay, there is another method of solve this type of problem, but I think this method is more easy. So now, according to this calculation, what is the value of function of m? M is basically x y square minus e to the power 1 by x cube. So x y square e to the power 1 by x cube, and we have to multiply this by integrating factor 1 by x to the power 4 dx. Okay. Now here's if we multiply this term by integrating factor, and in integrating factor x involved, so we can remove this calculation. Okay, so let me write here 0 equals to c. Okay, now just you have to solve this integration. So integration y square by x to the power 4 dx and minus 1 by x to the power 4 e to the power 1 by x cube dx. Okay, equals to c. Now it's very easy. Here this y behave like a constant. We can take this y square outside of this integration. So it will be x to the power minus 4 dx. And if we take a substitution here, so let 1 by x cube equals to z. So it will be minus 3 by x to the power 4 dx equals to dz. Okay. So dx by x to the power 4, it will be dz by minus 3. Okay, so it will be e to the power z minus plus 1 by 3 dz equals to c. Okay, so y square x to the power minus 3 divided by minus 3 plus 1 by 3 e to the power z, means integration of e to the power z is e to the power z. So if we put the value of it z here, so it will be e to the power 1 by x cube equals to c. So this is our general solution. You can modify this equation little bit, like e to the power 1 by x cube minus y square by x cube equals to 3c. Okay, so in this way we can apply the first rule. Okay, now come to the second problem. Okay, so pause this video and try to solve this problem by yourself. Okay, so now in second equation, if you compare this equation with general solution, then the value of m is y to the power 4 plus 2y. Okay, and the value of n is xy cube plus 2y to the power 4 minus 4x. Okay, now derivative this function m with respect to y, and derivative this function n with respect to x. Okay, so if you derivative this function with respect to y, it will be 4y cube plus 2, and if you derivative this function with respect to x, it will be y cube minus 4. Okay, now calculate. So basically this value is not equals to this value, this value is not equals to this value, so we can easily say that therefore equation 1 is not exact. Let me consider it's equation 1. Okay, now we have to find integrating factor. Okay, so now calculate the difference of this So what is the difference? It will be 3y cube plus 6. So we can take 3 common. So it will be y cube plus 2. Okay. Now you have to think that if we divide this difference by n, is it possible to get a only function of x or only function of y? It is not possible if we if we divide this difference by n. But instead of n, if I divide this value by n, so it will be y to the power 4 plus 2y. So we can take y common. So it will be y cube plus 2. Okay, 3 by y. Now I can say it's a only function of, even you can consider it's a function of y. So it is a only function of y. Okay. Now find the integrating factor. So therefore the integrating factor will be e to the power integration minus 3y y dy equals to e to the power minus 3 log of y. Okay. So it's very important when it's only function of y, you have to take this minus sign here. Okay. Remember. Okay. Now it's very simple. This value, it will be 1 by y cube. 1 by y cube. Okay. Now you have to find the general solution. What will be the general solution? Therefore, the general solution of given equation 1, it will be integration m. So let me check the value of m. It's y to the power 4 plus 2y, y to the power 4 plus 2y into 1 by y cube dx plus integration n into integrating factor. So n is x y cube plus 2 into y to the power 4 minus 4y minus 4y. Okay. Then into integrating factor, 1 by y cube y equals to c. But here this term, it will be x3. Okay. Now it's just a simple calculation. The first part, I think it's only function of y, but we have to integrate with respect to x. So you can directly write this in the form of y plus 2 by y square into x plus, so we don't have to calculate the first term, but for the next term it will be 2 into y only minus 4 into 1 by y square dy equals to c. Okay. Okay, if we integrate this with respect to y, so it will be y square minus 4 by minus of 1 by y. So we can write in this way. So it will be our general solution of the given differential equation. So in this way, we apply the first and second rule to solve any differential equation. Now it's your job to find the general solution for this one. Okay. So in next video, I will explain how to apply rule number 3, 4 and also 5. Okay. But try to solve at least one problem. Okay.